So this is the second video detailing how to create a machining operation for CAM project number 1. In the first video, um, dealing with the programming, the operations, I showed you how to create a 2D adaptive clearing operation, which you can see once I click on the program, I can see the toolpaths. Now for the second operation, what I want to do is I want to cut out this outside contour. And my preferred operation for that is the 2D contour. You can see by the description that's pretty much exactly what I want to do. Now, real quick, let's talk about essentially what we're working with here. We're working with a larger, probably slightly larger piece of stock, and we are cutting out essentially the shape from that larger piece of wood. We do have to think about how this piece of wood is being held down in the CNC machine. So the larger piece, assuming this is cut from a larger piece of stock, the larger piece of stock probably has some type of a clamping system. Perhaps it's screwed down in essentially scrap areas. It could be a vacuum system, although that's probably a little bit less likely because those are more expensive. But what I'm getting at here is that we need to account for this when we cut out the outside, because we don't want this coming free and loose to a point where the cutter can leave tool marks on it, or it can bounce around. And worst case scenario is, the cutter could essentially, the machine could throw it because it is loose. It could pop up and the cutter could hit it, and that's not what we want to do, right? We spent all this time and effort making this piece. We want it to look good. So I just opened the contour operation. Let's select the tool, which for this is going to be a 1/4 inch end mill. It's probably one of my preferred tools for general machining, especially for cutouts and things like that. It's already set for my feed per tooth, my feed per revolution, and my RPM, and then once you put those in, it calculates the rest. I really like doing that in the tool library itself, but it can change depending on materials that you're using. And the next tab over, we have to select our geometry. Now, since we're cutting it out, I'm going to select that bottom contour. And you can see it lights up blue indicating that. And I'm going to want to leave tabs. This is going to be the way I'm going to hold this material in the larger piece of stock without it breaking loose. Now, the size of the tabs and the frequency, there's a lot of personal opinion here. Do what works for you. I like fewer, larger tabs. Personally, it's less for me to cut and clean up later, I feel like. I like the rectangular shape personally. My tab width, I'm going to do a 1/2 inch tab width. And for tab height, because this is a softer material that I'm going to be cutting, I'm going to do 0.1 inch. Whereas if it was a harder material, I could go a little bit thinner and it would probably be fine. I like doing by distance, and I usually put some different values in here to kind of see what I like. I don't think 2 is enough. I think I need at least 4, so I just, that looks perfect. So I just usually play with the distance until I get what I want. Now, like the other machining video, I recommend that you look through these different options to have a better understanding of what you can do, even though we're not using them for this. It is really good to know what changes you can make, because a lot of times you'll run into problems, and the more you know, the more options you have to fix your problems. I'm not going to change the standard heights, the plane heights here. I'm just going to make sure that the bottom is accurate. And I know the thickness of my model was pretty accurate, so I feel comfortable doing model bottom. And the negative 0.75 distance tells me that I'm right on, because I know the distance or the thickness of this piece of stock is exactly 0.75 inches. I could also do selection is another one I do a lot as well. For passes, what I want to do here is I don't want to dive down and do this in one pass. Generally, the rule of thumb for cutter depth is you don't want to exceed the diameter of your cutter. So if I have a 0.25 or a 1/4 inch diameter cutting bit, then I probably don't want to go deeper than a 1/4 inch. Now, Are there circumstances where you can do this? Sure, everything is subject to change, but it's a pretty good rule of thumb, and starting out, it's definitely going to be what you want to follow. I'm not going to change anything here. It actually works for me. The finish feed rate's close enough. I'm fine with that. But I'm going to go to multiple depths because I don't want to cut this all in one cut. That might be a little aggressive for my cutter, especially since it would be diving into what is essentially untouched material. If I were just on one side where I could climb cut up, then I would probably go deeper here. Or if you, once again, if you hover over, it'll give you a pretty good explanation of what this is. And it's essentially the maximum step down. And my maximum step, I want it to be the diameter of the cutter. So that's 0.25. I'm not going to tell it step downs. I'm going to let it figure that part out. I know I'm going to have to come back and sand the edge, so I'm not too worried about finishing step downs because, like I said, I'm going to lightly sand it. But that is something that you do want to be aware of, is finishing motion. Sometimes stock to leave, if your finished size is very sensitive and you need to get really accurate, that can be a good way to do it. But for our purposes here, this should work just fine. One option you could do would be even step downs, but unless I'm doing something very specific, I'll let the computer figure out the best way they think to do it. I have some red here that I know I need to address that, or I'm not going to have, I will have a problem. It won't calculate. So it tells me that this can't be any more than the height of the cutter. And it's still not liking that. What if I go just below? Now, let me do it. All right, I better read this then. Safe distance is higher than the feed height. Consider adjusting the safe distance, or will be matched. This needs to be less than the cutter. Lead-ins and transitions. I personally like ramp. I feel like, especially depending on whether your end mill is a center cutting or not, ramp can allow you to get depth slowly, which a non-center cutting end mill can do. So I generally employ ramp, but sometimes if I'm in a very small area, ramp is not something that I can do. But in this case, I think ramping will actually work really well. So I'm going to include ramp with that. Now I'm going to go ahead and run all the other defaults here. If you don't know what you're changing, I recommend to leave it as the default. And if you need to go back and change something, then you absolutely can. But until you have a better idea of what these different options do, I would say don't go change everything. Just kind of my outlook on things. Now you can see the toolpath came in here. And what you can see right from the tool cutter representation itself is it's ramping down. You can see this ramp on this long side here, coming around, getting to the bottom, and then doing its cuts. So you can see this is where it comes in, this is where it comes out. Overall looks pretty good to me. Now at this point is where I would say you should simulate it, watch the toolpath, and make sure you are indeed getting what you want. And that'll be the next video, is how to create the simulation. But this is exactly what I was looking for the contour. And as you can see here with the tabs, you can see the tool path where the cutter comes up and over the paths. So this is, like I said, exactly what I wanted. I'm happy with that, at least for now. I suppose after the simulation, there could be something I want to change, and that'll be the next video.